Now I'm going to discuss Windows credentials as a means to authenticate and authorize with WCF services. When you use Windows credentials, you're using the operating system security. You can configure your services to use Windows authorization, but some of the bindings, such as NetTCP, support Windows by default. The credentials will default to the currently logged on user. However, you can change this by setting the Windows.Client credential property of the proxy. When you want to authorize, you can use the principal permission attribute to perform a demand against a name or a role. Now, I'm going to show you how to configure your services to use Windows security, how to change the client credential, and how to authorize a user. Here I have a solution with a few projects that are pre-configured to support Windows credentials. I have a service, and the contract has a couple operations in it. The getTemperature returns a temperature, and the whoami will return the authenticated user's name. We also have a host that's hosting that service and a client. In the host, we're hosting the weather service. And notice how we have the principal permission mode saying use Windows groups. Also, on the binding, we just created a binding up here. We set the security, message, client credential type to use Windows. So we're going to use Windows groups, and we're going to use Windows as the authentication. In the endpoint, we added that new custom binding that we customized with the credential type. And of course, we start the host and run it. Now that we have running host, we can configure a client to use it. And here is the client. Notice that its client credential type is set to message credential type Windows. Now, if we did not specify anything else, it would use the currently logged on user, which would be me. However, when you want to change who that user is, you go into the proxy, client credentials, Windows, client credential, and then you can get to the domain username and password. And here I set domain to the local machine name. Otherwise, it would be the name of whatever Active Directory domain you're on. And then I set username and password to a user that I added to this system. So these belong to my local Windows system. And then I call the proxy. And then I call who I am, which prints out who am I. Now, we're already authenticated through Windows, so that works just fine. But we need to implement authorization, especially in this who am I, to make sure that it returns the right result. So over here in weather service, here's the implementation of who am I. And this attribute up here, this principal permission attribute, it allows us to specify who's allowed to use this service method. So we use a demand, and then we specify the role. This test group, that's a group on my local Windows system. And I already have that test user assigned to this group. Therefore, when that request comes in, it's going to be authorized against this group, and it will get in. If that user was not in this group, then the client would receive a security exception. I'll talk about exceptions later. The client would really receive a fault exception. But if the user is in that group, then they get in. Now inside of here, I'm using this thing called a service security context. Well, every WCF service runs in a security context. So I'm grabbing the current, which is the security context that this service instance runs in. And I'm using this Windows identity property and grabbing the name. Now this Windows identity is an iWindows identity, which is an identity, and it is part of the built-in .NET security that has iPrincipal and iIdentity, which can be customized based upon the type of technology you're using with your security. For example, this is iWindows identity, but you can also have iGeneric identity, which can be used with systems like ASP.NET and so on. Now I know I'm using Windows security so that I can look at Windows identity. However, what if I was using another type of security like username or X509? Then this security context would not populate Windows identity. That would be null. The security context would populate primary identity. So it's safe because I know I'm using Windows here, but if I wasn't using Windows, I would use primary identity. So this is returning the name. So I have that configured. So I have a service, I have that service hosted, and I have a client that consumes a service. Now in Visual Studio, for testing purposes, I have to set up the projects. Notice how I have the host first and then the client. And I'll press F5 to run this. And here's the host running in the background. And we have two entries. There's the call to get temperature. And in the next line is the call to who am I. And you can see that the Windows identity returned Seattle/test user. And that was the user that we specified in the client as authenticating with Windows and authorizing with the who am I method. And that's how you configure Windows credentials. When securing your WCF services, you may want to use X509 certificates. In a nutshell, an X509 certificate allows you to perform authentication or protect the message contents via encryption or digital signing. In your development environment, there's this utility that you can use. It's called MakeCert. And what this does, it allows you to create a certificate for development purposes so that you don't have to rely on the real certificate that you would get from a certificate authority. This particular example has an SR option, which is the storage container, which could be current user or local. The SS option is for my personal folder, and you have different certificate store folders within each of your categories of current user or local machine. The A option is for the encryption algorithm to use. In here I'm using SHA-1. N is the name, and it's a common name, and I'm going to use Learn Now. Sky option says that, okay, I want to be able to do key exchange. And the PE option is for export. Now the technique I'm going to use is to open the Microsoft Management Console, the MMC, and load the certificate utility into the current user store. Then I'll copy the certificate that was created by MakeCert from the personal store into the trusted people, and that will enable the client to trust that certificate also. So let me show you how this is done. So here I have PowerShell open, and I want to show you how to use MakeCert to generate a certificate. In this example, I have the MakeCert utility. I'm going to generate the certificate and put it in the current user store, and this will go into the My Personal store. I'm going to use SHA-1 as the algorithm, name it Learn Now, do key exchange, and export it. So I'll just press enter. It says it succeeded, so let's go see what the results is. Here I have my certificate current user open. You can open this by typing in MMC, selecting OK, and then when you get a blank MMC console up, you can go to the File menu, select Add Remove Snap-in, and select Certificates. I have one in there now. And then select Current User, and then here you are. In the certificates, I'm going to type L, and we don't see it in the list. That means we need to refresh because we just added it. I'll type L again, and there's our Learn Now certificate. Now I'm going to right click on that, copy, and go down to Trusted People. And then I'll paste that in. And now we can use that certificate in both the service and the client. Another type of credentials you can use with WCF is called username. Username credentials are for custom authentication and authorization. The primary use case for this is when you're not guaranteed that your client will be on the Windows platform, or they're external to your system and you don't want them integrating with your Active Directory or Windows authentication service. And so this is ideal for that. To get started setting up username credentials, you would just configure the credential type as username. Then you go in and you set the username and password in the client. To authorize, you would have a membership system set up, and we're going to use the ASP.NET membership. Even though it's called ASP.NET, it's really ideal for any type of generic service. Then to authorize, I'm going to use a principal permission attribute on a service operation. Now this ASP.NET authorization, it still needs to be set up. So here's how you do it. I'm going to set up the database by using this utility called ASP.NET_RegSQL. This utility lets me set up the database with a set of tables that support membership, roles, and other services. But we're mostly interested in just the membership and roles. Once you have that database in place, then you can set up users and roles. And then to authorize, you can use principal permissions. Now I'm going to show you how to set up the database and then go use username credentials using that ASP.NET membership store as the back end to support the custom authentication and authorization. Before using username credentials, I want to set up the security store, which is the ASP.NET membership provider. And here I am over in the Windows Microsoft.NET Framework version 4 folder. And there's a utility here called ASP.NET_RegSQL. If you run this, you can hit Next. It's just a wizard, and it says configure or remove the application settings from a database. And I'm going to use the local machine, and the database I'll use as the default. I'll just set it to ASP.NET-DB. And then when you hit Next, it tells you what you're going to do, and if you hit Next again, it's going to generate the DB for you. Now I already have a database set up, so I don't need to go through this process. Now, over here in the application, I've set up this website because now I need to go into the database and set up the membership for it. Now, one of the techniques I use is I go ahead and connect to the database here. I'm going to say add a connection. I use the local machine. Go over here and select that, not AdventureWorks. I need ASP.NET-DB. And I test the connection. And then say OK, and I get a connection right here. I can right click on this and say View Properties. And on the properties, I have a connection string. I can select that, say Control A, and then over here in my web.config file, I can set that connection string right there from what I got in the properties. I named this ASP.NET-DB. So I'm over here, I've got a website. I added this by going to Solution, Add, New Project, and then I went to Web, and I selected a new website. In this website, I open web.config, and that gives me this menu that says website right here. But also, to configure this, after I added that connection string, then I added this element called system.web. This usually belongs to the ASP.NET infrastructure, but that's okay, I can use it here. The authentication mode is set to Forms. That's as opposed to Windows, and Forms really means that in ASP.NET you're using your own custom authentication. Since we're using custom authentication, then this is the correct thing to do. And then I have a role manager to manage roles and a membership to manage users. Remember that you always have to enable your role manager. Otherwise, roles are not turned on. In each one of these providers, I've set a default provider. I only have one provider for each WCF role provider, and that matches the name of the provider. Same for the membership. Now in the provider itself, I added a new provider, and this one is SQL Role Provider, and this one is SQL Membership Provider. These are providers that are built into .NET, and you could just use them. The connection string name matches the connection string I created up there. And this database can hold multiple applications. So for the application I'm building, I want to use this as the name of the application, and this is what will be used to store credentials. Now, I've configured ASP.NET security in this website, and here's the reason why. Over on the website menu, and this only shows up when you select an artifact in the website, I can go to the ASP.NET configuration and then go over to the provider, and you can see that I have the provider name that I created selected as the provider in this application. And then over on the Security tab, you can manage users and roles. The first thing I did is I went and created a role. I'm going to hit Create or Manage Roles, and you can see that I created a test group. Back on Security, you can say Create Users, and I hit Create Users, and I created a test user. And I assigned that test user to the test group role. So, now my security is set up for me. Within this same solution, I have a couple projects. I have a client, and I have a service, and I have a host for that service. So what I want to do is go to the host, open up app.config, and here you can see that I configured the service host with the same settings that I have in my website. This means that I'm using the same database and the same configuration settings to authorize and authenticate that user. In the host, I configure security, and so I have a service host instance, and I've grabbed a reference to the credential type right here so that I don't have to retype all that over and over again. But before we go back to roles and membership, I'm going to show you one thing having to do with the certificate authenticating itself with the client. I'm using this API to say set certificate. My store node location is current user, so that's the current user store. This is the personal store where that certificate resides. And I'm saying which certificate to use, find it by subject name, and its common name is LearnNow. This next statement right here says that I don't have a certificate from a certification authority, such as VeriSign or DigiCert or Thought or one of the other certification authorities in my trusted root. I only put that certificate right there. So I'm setting the certificate validation mode to peer trust, which means that it's not going to go up my call chain, my verification chain of trust, to the root certificate to validate this. So this is only for development purposes. when I'm shipping to production, I'm not going to be doing peer trust. I'm going to have a certificate that's validated by a certification authority, and this will not be in here, and this will point at my certificate. Now, certificate-wise, over on the client side, I have an endpoint. And this endpoint points at the weather service, but I've set its identity to the name of the certificate. So now when the client uses that endpoint, it's going to use the identity of the certificate to validate the server. So that was the X509 certificate validation part of that. Now let's go back to the host. And we'll look at the username authentication. Here we have, on the credentials, we have username authentication, and the validation mode is set to the membership provider. So that means I'm using ASP.NET membership, and it also demonstrates that WCF works with this ASP.NET membership provider. I'm also using ASP.NET roles as my principal permission mode. So these go together. I use membership and I use roles. Now down here in the next section, I set up a custom binding. I'm using message mode in this binding. And then inside of that binding, I go into its security message client credential type. And this says I'm using username certification. So I'm using username certification, and I'm using the ASP.NET membership provider as the method to perform authentication and authorization. Here I set up an endpoint that uses that binding. So now I have my host set up to use membership. It's configured right here. And over on the client, then I'm grabbing the binding out of the proxy. And in the binding I set the security mode, but I also set the client credential type. Set it to username. So now both the service host is configured for username credentials, and so is the client. Again, I'm setting the client to use Pure Trust so that in the development environment it doesn't go up the chain of trust looking for a certification authority. And then I'm using these client credentials. I'm saying a username password credential, and I'm creating a new one of those. I'm getting an instance of the username credentials assigned to the proxy, client credentials, username. So with that username credential, then I'm setting the username and I'm setting the password. And as you saw earlier, this username is already configured in the database. That's the password I gave it. So I have a proxy that's configured with username credentials, and I can use it to call the service. Here's a call to a service operation called Who Am I? So this client is going to call these two operations on the service. Over on the service, Who Am I is using a principal permission attribute with a demand for this test group. When I set up the database, I created a role that was named test group, and then I assigned the test user to test group. So when test user goes and calls this through username authentication, it will pass. If the client uses a username or a password that is not in the database, they will receive a security exception. Now, Who Am I uses this service security context, and every WCF service has a security context. Grabbing the current one for this service instance, And here I'm using primary identity and grabbing the name. If I look at the properties here, I also have a Windows identity, but this is not Windows. Therefore, I'm using primary. Grabs the name, returns it to the client, and the client prints it out right there. So, to run this, I would right-click and say Set Startup Projects. And what I want is for my host to run first, so I have it in the list first. Set it to start, and then the client too. And then when I press F5, then you can see in the background that the host started, and then the service called, got a temperature, and then said, I am test user. This is the name of the user that was returned from the server. So now you see how to use username credentials and how to set up ASP.NET as the provider for custom authentication and authorization.